In this video, we're going to learn the fundamentals of using user parameters in Fusion 360. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to dive into user parameters. Now, I've already done an example video where we looked at creating a hole pattern that updated based on feature size. So if you haven't seen that, definitely go back and check it out. We talked about this hole pattern size and we worked through the entire process to make it. Let's do a quick recap of what that entails. So from our modify panel in Fusion 360, we've got change parameters. We can modify things like the length and width of the plate, and this will automatically update the number of instances in the pattern. So this is extremely helpful if you're making designs that need to update based on those values. We also took a look at a gate pattern. This is the same thing. We can modify all the values, making sure that it updates based on certain parameters. So for example, if I wanted to take this out to 80 inches, if I wanted to increase or decrease the height, you can see that it's able to update these. This is all based off of some basic parameters and a single equation that takes the gate length divided by the board width and then divides it by another value and rounds it to the next highest or lowest whole number. There's another example, and this is a basic example of a table. Now, this table, again, has some handmade parameters. We've got a couple of things that we can update. Now, this doesn't have any advanced functionality. It doesn't use any limits like rounding or ceiling or floor. We can just simply update the values in our table. We can modify things like the height of the table and have it update on the fly. So using these parameters is an important aspect of parametric design, but we need to understand a lot of basics to make that work. So the first thing I'm going to do is start a new design. I'm going to modify my documents. I'm going to change the units to inch. And we're going to get started learning the 7 different points of user parameters. Now, if you want to skip ahead, if you're familiar with dimensions and constraints, by all means, skip to the next chapter. We're going to be talking about dimensions, constraints, and linking dimensions in a sketch. Then we're going to move on to creating basic user parameters, naming them on the fly. We're going to learn how to link them to features. We're going to do advanced operators like we did in our previous example, things like ceiling, floor, and random. And we're also going to talk about sketching construction geometry and driven dimensions and how those impact things like our user parameters. And at the very end, we're going to talk about the limits, things that we can't do with user parameters. So again, getting started, we're going to talk about dimensions and constraints at the very beginning. So we're going to start a new sketch, pick any sketch plane you want, and we want to begin thinking about dimensions versus constraints. And the reason this is important is because we need to know how our design is going to update. So we're going to get started with a 2-point rectangle. I'm just going to stick a 2-point rectangle here in the upper left-hand corner. I'm going to switch to center rectangle. I'm going to put one in the upper right-hand corner. And then I'm going to put a center rectangle at the origin and then hit escape to get off my rectangle tool. So we have 3 rectangles, very similar, but there are some key differences here. The first rectangle we created, the sides all have horizontal or vertical constraints, and the corners are coincident with the other edges. What this means is there's no central location or center point, and we can very easily select a constraint and delete it and not have a rectangle anymore. So in some instances, this might be a quick way to start a design. But the reason that this is problematic is it's less predictable and harder for us to control when we're starting a new design that we plan to update based on parameters. So I'm going to box select this, hit delete, get rid of it, and talk about the center point rectangle here. So the center point rectangle automatically includes some construction geometry. These go from the corners and they meet in the middle where there is a sketch point that's added at the midpoint of each line and their intersection. You'll also note a difference in constraints. There's one constraint that's horizontal, and then we have a perpendicular constraint in one corner, and the rest are all parallel. So this parallel constraint deals with the upper and lower edges. This one deals with the right and left. And this perpendicular ensures that it does stay a true rectangle. For this one, if we get rid of that horizontal constraint, now what we have is a center point rectangle that can move about freely, change angles and orientation. So when we talk about this, we need to think about the coordinate system that we're working within. If we add dimensions, I'm going to do this real quick as an example. You don't need to follow along. But if I add a dimension of 4 inches and I add a vertical dimension here, making this aligned of 2 inches, we now know exactly how to control the length and width of this rectangle. But it doesn't really help us with the orientation. If I snap this to the origin, for example, we don't really know how that's going to update in 3D space unless we also control the angle. So when we're thinking about a new design, we have to think about how it's going to update when we change our dimensions. And this is why it's so powerful for us to build our designs about the origin. It helps us know exactly how things are going to update. For example, if I change the width of this rectangle, we know that the width is going to be symmetric about the origin, or in this case, the YZ plane. We know that if we change the height, that it's going to be symmetric about the XZ plane. So these are important considerations when we begin our designs and we think about the ways in which we want them to update. Now that we've taken a basic look at sketch constraints and how they're applied to things like our rectangle, let's go ahead and let's start adding some dimensions. So you can use D on the keyboard, or you can simply go up to Sketch Dimensions. I'm going to start by adding a 2-inch dimension by manually hitting 2. And for this one, I'm going to add a 5-inch dimension, manually hitting 5. This design is now fully defined, which means that we no longer have any open entities that can move around freely. You'll note that all the sketch entities, including the construction entities, have turned black. If I add another dimension, let's say that I wanted to add this dimension here, it's going to prompt me that I'm trying to over-define the sketch. For right now, I'm going to hit cancel, but just note that over-defining a sketch is problematic downstream. Because you don't know how things are going to update, or you might be adding more constraints that'll limit the update, it's important that we fully define sketches in a way that makes sense. For a rectangle, it's length and width. That's the easiest way for us to define its size. But what happens if we have 2 rectangles in this design? Let's go ahead and make another center point rectangle. I'm going to place it above, and then I'm going to hit escape to get off my rectangle tool. I want this to be fully defined. And what I want to do is I want to add some constraints. So in this case, the center point of my 2-point rectangle, I'm going to hold down Control, select the origin or the center point of the rectangle below, and I'm going to say that these are vertical. Next, I'm going to use my equal constraint, and I'm going to set the vertical edge equal to this vertical edge. I'm going to hit escape. Next, I'm going to use my dimension tool. The reason I'm going to use a dimension tool is I'm going to show you a different way other than using the equal constraint. So I'm going to select this edge, and when it asks me for my dimension value, I'm going to click on this 5-inch, which is named D4, dimension 4, and that's because it was the 4th one I applied, and I'm going to hit enter. So you'll notice that this value is 5 inches, and this value is 5 inches. If I modify this to be 4, they both update. The fx is representing an equation or a relationship between the two. Next, I'm going to dimension the vertical distance between these two. Let's say that I want it to be equal to this value, but I want it to actually be a little bit more logic-based. I want it to be that value, but I also want to increase it a certain amount. So I'm going to multiply this by 2 by simply putting the asterisk and the number 2 and hit enter. This makes it 8 inches. So if I drop this to 2 inches, both rectangles update and this value drops down. If I make it 5 inches, now they're 10 inches apart. So using logic, we know exactly how things are going to update, and now we can control it based on some simple parameters. Let's go ahead and add one more rectangle. This time I'm going to use a center point rectangle, and I'm going to place it over here off to the side. Again, we want to use dimensions and constraints to fully define this. We want it to be the same size as all of our other rectangles, but we also want to make sure that it stays exactly centered between these two rectangles, but off to the side. So I'm going to use my equal constraint, and I'm going to set the vertical edge the same as this one, and the horizontal edge same as this one. Because they're going to be the exact same value, simply clicking on them to make them the same or using an equal constraint will yield the same results. The next thing I need to do is add some dimensions. I want to make sure that this to this distance, the horizontal distance, is going to be double the width. So what I'm going to do is I'm going to select this, I'm going to apply a horizontal distance. I'm going to select this value and multiply it times 2. So again, it's going to stay double that distance away. If I reduce this to 4, you can see everything moves in. Now I need to control its height. We know that the center position between these two is double this value. So what we want to do is we want to make sure that the height position is going to remain half of that value. Well, since we already know that this value and this value are double our width, we can simply just use the width value. Even though the width value is intended to drive the width of the rectangles, it actually will work as the height or the distance between because of this equation. Now, this is where it gets a little tricky. You have to really think long-term in the way your design is updating. If you decide to change this amount, for example, if we say instead of times 2, I want to do times 1.5, we're no longer in the center. So you have to think long-term how your design is going to update. And if that's the case, you might need to actually change this value to be this value. We're going to put it in some brackets. And then we're going to divide it by 2. Now, remember that this is D6 and not D4. We want to make sure that we only use this value here. So we're going to divide it by 2. And now if we decide to change this formula to say, let's multiply it by 3, now it's going to move evenly. So again, just because a dimension works out in this instance of a sketch, you have to really think long and hard about how you want your designs to update. The next thing we want to think about is, what if we want another version of this? Does it make sense for us to draw another rectangle, apply all these dimensions and constraints, or does it make sense for us to create some sort of symmetry using mirror? This is an instance where I'm going to add a vertical line. I'm just going to go between these two center points. I'm going to hit escape. I'll convert it to construction since it's not going to be needed. And then I can either create a mirror, or since I already have another rectangle, I can use the symmetry constraint. Now the symmetry constraint really works based on individual objects, so it gets a little tricky when we have multiple lines that we want to mirror. So I'm going to delete this rectangle, and then I'm going to use the mirror. We select what we want. I'm going to go ahead and select the outside of the rectangle, as well as the construction geometry and that center point. That'll be important if we ever want to use it downstream. I'm going to select my mirror line and say OK. Now that is a complete mirror with symmetry. So if I modify anything, say we modify this equation, you can see that everything moves properly. It's a good idea for you to test this out, manipulate these values, make sure that everything does move how you expect. So you can see everything is updating properly and it looks okay. So I'm going to finish the sketch. I'm going to zoom back out, and I want to extrude all of these. So I'm going to simply go ahead and select all the profiles. For right now, the amount doesn't really matter, but I'm going to just go 18 inches and say OK. This is a good time for us to do a quick save to make sure we don't lose any work. For me, I'm going to go ahead and call this UP for user parameter, and I'm going to call it practice. So that obviously is a very simple single example, but the theory behind it should apply to any of your designs. Depending on how complex your sketch is, you might have to spend a little bit more time thinking about those parameters. At this point, we did everything inside of the sketch. We linked values together, we added constraints, we made some simple equations. But there is another way that we can do this, generally before we start our design. The way that we can do this is from modify and change parameters. Change parameters, if you've done the previous example, you would have seen this before. However, this is different because now we have a section with model parameters. If we expand this, we can see our original sketch as well as our extrude. All of the dimensions that we created have been exposed in here under model parameters. If you want to manipulate any of them, if your designs contain multiple sketches and multiple features, it can be helpful for you to simply place them in your favorites by checking the star. That means even if you have a long list of model parameters, you can always get to these. You'll also notice that it shows the name of the file. This is UP practice. And if we expand this, you can see that it's showing .sketch1. If we expand our sketches, we're in sketch 1. Linear dimension 2. D3 and D4 are linear dimension 2 and 3. So this is the common name or the username, and it's linked back to those sketches. This is the name in which we expose when we click on a value and link it to another value. If we expand our model parameters again, you can see here that D5 is D4, D6 is D4 times 2, D7 is D4 times 2, and D8 is D6, which is this one here, divided by 2. We can manipulate any of these on the fly directly inside of here. For example, I can change this to 3, I can have it update. I can change this back to 2, and we can see it updates properly. So these values will be extremely handy knowing that we can expose them. But what if we want to create them beforehand? What if we have a good idea of what our model should do and we want to begin creating them before we start modeling? Well, we can go into the user parameter section and hit the plus icon. So we need to start typing, and there are a few nuances that we need to understand. First, the names cannot contain any spaces. So what I'm going to do is I'm going to say box underscore width. You can also simply use a capital letter for the second word. It just depends on your workflow. So underscore width for me, the units will be inch, and the value is going to be 3 inches. I'm going to repeat that process, and I'm going to change this to box underscore length. And this value is going to be 5 inches. And the next thing I want to do is I want to talk about the parameters that are exposed in the extrude. This is something we're going to cover a little bit later, but you'll notice that the along distance also has a dimension D9 and in inches. Then there's a taper angle. Even though we didn't apply one, the taper angle automatically comes in with this feature, and it's set at 0 degrees. If we manually manipulate this value, you can see that we can increase or decrease the taper of these objects. I'm going to leave it at 0 for now, and we will get back to exploring these inside of the features, but for right now I just wanted to at least mention that they are created and exposed in this dialog. So now that we have our box width and box length, we have to think about what that really means. We can go back to our sketch and we can link them back to those original values, or we can even do it here. Now, instead of D3, what we want to think about is our box width. So keeping in mind that these expressions are used in other places is an important consideration. So you can see that D3 and D4 in some cases show up later on. You can see D5 is equal to D4. So what I suggest is going back to your original sketch, if you're doing this after the fact, and think long and hard about where you want these values to be applied. So for example, the box width, I'm going to start typing B for box, and we're going to figure out if this is length or width. You'll notice here we don't actually have a numerical value, so this is why using the numbers or using the logic of the naming convention is going to be important. And if we relink this one, we're going to call this one box width. Nothing changed so far, but if we take a look at this, you'll notice that it's linked to D4. Let's go ahead and for a second go into our modify and change parameters dialog and see what D4 is referencing. D4 right now is referencing box length. So everything has connected properly because we didn't change the name of that original value. But if we want to build out a robust set of user parameters, we should really begin to think about converting these or creating a variable that helps control these. So for example, this value, D5, is simply controlling the width of this other box here. So this is a case where the equal constraint is probably a better option, and we don't really need to worry about this one. The next one down here, D6, was controlling the height between the two. This is a case where we really should have a user parameter. So I'm going to create a height offset. And if we look at our dialog, this is D4 times 2. Well, D4 is equal to box length. So instead of using D4, I'm going to use box length, and I'm going to multiply that times 2. It's the exact same value, but now we're referencing our user parameters rather than a specific dimension inside of the dialog. You'll also notice that D7 shares the same. And then the last thing is D6, which is going to be our height offset, and that's divided by 2. So we need to think about the position. So mid box position. And this is going to reference what was D6, which is now going to be our height offset. Remember, we want to always think about how we want these to update. And then we're going to divide that by 2. So now our height offset needs to be linked back to our sketch, and our mid-box position needs to be linked as well. So this value here is going to be our height offset, and this value here is going to be our mid-box position. Again, nothing updated because we really thought through the process and we figured out where these values should go. It's much easier if you pre-plan this, create the user parameters first, and then come back to the sketch. For this one here, I'm actually going to delete this dimension, and I'm going to use an equal constraint, making sure that the width drives it. So now we've created a robust set of user parameters that we can use to drive this design. If we modify any of these values, such as box length or box width, let's go ahead and hide these out of the favorites. So let's say I change this from 5 to 10. You can see everything has updated properly. If I change it to 6 or something smaller, 4, it updates. The box width isn't linked to anything else, but it does control these values. So let's set this to 2, and let's set our box length at 4. For right now, let's make a quick save, and then we can move on to our next topic. So at this point, we've learned a little bit about dimensions, constraints, and how to link dimensions in a sketch and create some very basic equations. The next thing we did was we replicated that by creating user parameters. But there is another way that we can create these user parameters on the fly and automatically place them in favorites. To do this, I'm going to start a new sketch. And what I'm going to do is I'm going to start on this top face. I'm going to zoom in. And what I want to do is I want to create a hole that is directly in the center of this. There are a couple things that we should think about. One, how do we know exactly where the center is? And there's 2 main ways we can do this. One way is to pull in the dimension value. The other way is for us to come up with some sort of reference with construction geometry. So for example, I'll show you both methods. First method is drawing a line from the midpoint here, and then another line to this midpoint. If we hit escape, we select both lines, and we make them equal. Their midpoint, or their endpoints I should say, is exactly in the middle of this body. So this means if we change the length to something longer or shorter, it's automatically going to update that center position. And this is a really robust way to do it. But we're going to talk more about that in a later lesson. So the other way that we want to do it is we want to reference the dimension or the distance of this edge. And again, there are 2 main ways to do it. One, we can apply a dimension here, which is automatically going to get converted to a driven dimension, and we can reference that. But again, I'm going to save this for a little bit later in the video. So the main way that we want to do this is we want to expose the original value from our user parameters. So if we expand, change parameters, and we look for the extrude distance, that's going to be 18 inches and it's D9. But how can we reference D9? It was in another sketch. So if we start sketching, let's just create a center point circle, place it about where we think is the center, and let's think about trying to reference D9. So if I just hit D on the keyboard and I reference a vertical distance here, if we try to type in D9, it works, and then we're going to divide that by 2. This automatically takes that 18-inch value of D9 and it puts it right in the middle. But now we need to add a vertical or horizontal constraint between these endpoints. The important consideration here we need to think about is, do these designs ever rotate? Right now we have a vertical or horizontal constraint. If your rectangles ever were to rotate in your design, then construction line with a perpendicular constraint to an edge is a much more robust solution. In this case, they're all extruding out normal to our sketch plane, so I know that they're always going to be centered. Even if we add taper, this is always going to be the center point of this face. So now that we have that in place, let's talk about the next step, and that's naming parameters on the fly. So when we add a dimension, for example, the diameter here, the main way that we do this is by simply entering a value. Let's say that I wanted it to be 2 inches. Well, what if I wanted to make that a user parameter or a favorite that I could use later on? If I double click on this and I type in, let's go ahead and do hole underscore dia for diameter, it comes in red. It doesn't let me do that until I put an equals and I put a value there. So now what I've done is I've created a user parameter called hole diameter or hole dia. And when we go to our modify, change parameters, it's automatically placed at the top in our favorites. Now this is a little bit different because it's not exactly the same as a user parameter. It still lives inside of our sketch, but it is a way to quickly create those favorites, those named parameters directly while sketching. Again, I think that the best option is really to do some pre-planning or some thought before you get into creating these, and it'll help you plan out your designs a little bit better, think about the interactions between sketches and dimensions and constraints, and pre-build these lists. And of course, you can open this dialog while you're sketching, so it can be done on the fly in here. But again, naming those beforehand can be a helpful way as well. But let's think about this. Now we're just simply placing a hole with an arbitrary number, 2 inches. It's not based on anything. What if we decide to change the length of the box? Well, in this case, what we want to do is we want that expression to be based off of box length. So I'm going to say box length divided by 2. It's still 2 inches, but if I decide to make this 5 inches, it's going to grow to 2.5. If I make it 6 inches, it'll grow to 3, and so on. So again, using this logic, determining how your design is going to update, if this hole is based off of the width of that face, or if it's based off of a specific hole size you need for a hardwares. So let's go ahead and say OK. And let's go ahead and finish the sketch, select that, and we're going to extrude it through all. I'm just going to go ahead and pull it down, but I'm going to change this dialog to through all. Through all is important, as well as using toObject whenever you're creating a parameter-based design. And that's because I can always go back into modify and change parameters. And if I modify the value of my box length, for example, 6 inches, we want to make sure that everything updates so that hole goes all the way through. If that wasn't going through all, then we wouldn't be able to update it properly unless we represented it based off of these other dimensions, which of course you certainly can do. So again, it's very important that we think about all of these different values and how we want our designs to update based on them. Which brings us to the next part of this. That's going to be linking parameters to features. So far, when we did our extrude, all we really did was we entered a value of 18 inches. And to change it, we have to go back in here, find the extrude, and modify it, or we need to add it to our favorites. What I want to do is I want to create a value, in this case, 18 inches, that allows us to create that extrude as a parameter. So we're going to hit plus. We're going to call this box underscore extrude, and I'm going to enter a value of 18 inches. Now we need to link it. Now you can do it directly in here by just linking D9 to box extrude, or you can go back to the feature. In this case, we're going to right click and edit the extrude feature and just add it in here. So I'm going to start typing B, select box extrude, and say OK. Now if we did everything right, it should be in change parameters right here at the top, and we can modify it. If we go to 24, you can see the hole position is directly in the center. If we go down to 12, again, it's still directly in the center because we're using that value to help drive the location of our hole. Box length is driving the location of the hole center to center, and we ended up using this value, D9, to control the location of the hole in Sketch 2, which brings us back to that. You'll notice here that D16 again is not represented by a user parameter. So if we ever needed to modify that or change it, we would want to think about if that needs to be its own parameter. Maybe it needs to be included as a favorite, so it's at the top. These are all important design decisions that you need to think about whenever you're trying to create a parameter-based design that you need to update. So now that brings us to our next topic, which is going to be advanced operators and functionality. Now, again, we covered this a little bit in that previous example where we dealt with the hole pattern on a plate. But let's go ahead and take a look at the Fusion 360 help file, which you can find in the description of the video. And let's just take a look through this. So the parameter references have a handful of things that it can already do. Algebraic operators such as addition and subtraction. If we scroll down a bit more, you can see that the order of operations, we have things like brackets, exponentials, we can do a negative value. There's all different things that we can do inside of our dimension dialogues anywhere in Fusion 360, but also inside of our user parameters. Next, we have our mathematical constants, in this case, just pi. It is important that we do capitalize the P and the I. I found that that's the only way that it works. If you try to do lowercase, it does not work. And last, we have our functions. Now, again, you've got some standard mathematical functions, cosine, sine, tangent, and so on. And then as we get down, we have things like floor and ceiling. These are what we used for our whole pattern example. Round, which takes it up or down to the next whole number. So for example, if you were at 1.5, it would round to 2. At 1.4, it would round down to 1. We have absolute value. We've got max and min. We've got log and natural log, and we've got power. So when we think about these, we want to think about how we can apply them to our design. Now, in most cases, they're not going to be very helpful. It's going to be a very specific case where you need to round up or round down. You need to find the floor or the ceiling, the next highest or lowest number, and you have to think about the logic behind that. So let's take a look at our example and see how we can apply something. So in our example, when we created this whole diameter, it's exactly half of the width of our part. So if we go into change parameters and we take a look at that, the location or the hole size is going to be based off of the specific width of our part. So again, if we go into that sketch, we've got our whole diameter, which is equal to our box length divided by 2. But what happens if we need to make sure that our whole diameter is a round number? And we want to make sure that it always rounds down. Well, that's where the function floor comes in, because floor will allow us to round down to the next whole number. So for example, if we were to change our box length value, let's say that we made it 6.25. The whole diameter is 3.125. But if we wanted it to be a whole number, such as just 3, we would need to modify this and include floor. So F-L-O-O-R, and put all of that in brackets. And floor does need to be all lowercase. We hit enter. Now it's going to round down to 3. And that's the same if we go all the way up to 6.99. It's still going to stay at 3 inches until we cross over to 7. And then it's going to round to the next highest number. But because we're talking about dividing it by 2, 7 divided by 2 will give us 3.5. If we want it to instead round to the next closest whole number, 3.5 would take us up to 4. So instead of using floor, we could use round. And round will ensure that we're rounding to the next closest number. So in this case, 7, which will give us 3.5, will round up to 4. If we were at 6.99, it's going to round down to 3. So again, we have to think about this logic and what it really means to our design, whether or not we want to round up or round down, or just use the round function to allow it to make use of whether or not it's closer to the lower number or closer to the higher number. For this example, let's set it back to 6. There is also one function at the very bottom of the help file called random, which can spit out a random value. We're not going to be looking at it here, but it could be interesting if you're trying to generate some sort of random pattern. You can use that function inside of your user parameters. Now that we've taken a look at most of the topics for user parameters, I want to circle back around to sketching and using construction geometry, and also talk about driven dimensions, because both of those are going to be important aspects of figuring out our design. I'm going to show sketch 2, which shows us the hole on this plate, but I'm going to repeat that process by sketching on one of the other faces. Now, of course, we could simply replicate or reuse our parameters and base off the center point of this edge here. But what we want to talk about is ways in which we can use our construction geometry and also use driven dimensions. So I'm going to do a single hole on this face, and I'm going to repeat it over here using a completely new sketch. So I'm going to hide sketch 2 now. I'm going to take a look at this. I'm going to start with a line. Before I start sketching, I'm going to change it to construction. I'm going to find the midpoint, which will be the triangle icon. It'll allow me to snap to it. I'm going to draw a vertical line. Notice that it's automatically trying to snap to horizontal for the midpoint. I'm just going to allow it to snap there and then drag all the way up until we get to the midpoint on the other side. If we hit escape, we find this midpoint, you can see it's still able to float up and down. So a couple of ways that we can handle this. One way is for us to make both of these lines equal in length, which will always find the center of that face. Another is for us to use another construction line. Find the midpoint, find the intersection, then we're going to make these two perpendicular. So why would you choose to do one over the other? Well, this option, pulling a reference off of another face, can be helpful if you're not just working with a rectangular face. Sometimes you might have geometry where it makes more sense for you to go corner to corner and find the midpoint, or it might make more sense for you to bring in multiple edges. For example, if you had a hexagonal option or a hexagonal geometry, then you might want to bring edges in from each corner point, and then you would make them all equal. So that's really going to determine how you decide where your construction geometry can go. But this will update based on any changes to our parameters. So for example, if we go back and we change the extrude distance, so this box extrude, if we set it to 16 inches, this is going to automatically update because we're using specific references such as the midpoints of edges. Next, let's go ahead and put a circle in here. And again, I'm going to hit D for dimension, and this is going to be my whole diameter. Notice that this is referencing another sketch. It shows a different icon next to it. But I want all these holes to be the same, so I'm simply going to select that and hit enter. It's linked to this one, so if I go back to our parameters and change anything, it will allow it to update automatically. And again, it will use the floor, ceiling, or round options that we applied to our user parameter. So for this one, let's go ahead and finish the sketch. E for extrude. And instead of doing extrude through all, I'm going to use the option to object and just select the back side of this face. Again, that is a parametric link to the thickness of that part, so it will update properly. Let's go ahead and repeat this process over here. In this case, what I'm going to do is I'm going to draw my circle first. I'm going to hit escape to get off my circle tool. And notice that with the line, I was able to find the midpoint, but I can't manually find that midpoint here. So what I'm going to do is create a sketch point, and the sketch point will snap. I'll hit escape, select that, select the center of the hole, holding down control, and make them vertical. Now that automatically created that vertical reference. Another thing that we could do is we could project one of these holes and make a horizontal reference. In this specific instance, in this design, that would work fine. But again, we really want to think long and hard about how our designs need to update. So in this case, what I'm going to do is I'm going to apply a dimension. I'm going to select this edge. I'm going to say OK to this warning. And you'll notice that my dimension is now in brackets. Those brackets are representing a driven dimension, which means this dimension is not driving the sketch. It's coming in as a reference. It's telling us exactly how long it is. So if I want this to be based off of that driven dimension, I can simply select it and divide it by 2, which will automatically put the hole right in the center. And then I can go ahead and select hole diameter, hit enter, and you'll notice that it's still underdefined. If I try to move it or change it, everything appears to be fully defined, but this is giving me an underdefined warning. And part of it is because the driven dimension is not inside of this sketch, and it's not controlling the height of this specific instance in this sketch. So this is, I don't know if I would call it a bug or not, but it's not going to give you the fully defined sketch like you would normally see. It is going to still look underdefined. If we finish the sketch, we don't get the lock icon here. Using driven dimensions in parameters and functions is relatively new in Fusion 360, so I'm going to assume that this is just something that has slipped through the cracks and hopefully will be fixed in future updates. So now that we've looked at defining that, let's go ahead and create an extrude. This time I'm going to just pull it down. Again, I'm going to use toObject. toObject is a great option, especially if you're dealing with non-planar objects, or through all, depending on what your end result needs to be. So now we've taken a look at ways in which we can use driven dimensions, construction geometry, and a whole host of different options to essentially create the same thing. Which one you choose to use in your designs is really going to depend on what you're making. In some cases, we're dealing with very simplistic geometry, so the easiest option makes the most sense, using the equal constraint wherever possible to limit the number of dimensions that we have, and making sure that we make user parameters so that it's easy for us to update. You don't really want to have to scroll down through a bunch of different sketches and a bunch of different dimensions to figure things out. And even though it is very helpful to put things in as a favorite in the user parameters, sometimes it can be really hard for us to understand what those actually were. So for example, this one here, this linear dimension, just has D16. That means absolutely nothing to me. So it's hard for me to understand what this value is and why I should change it. However, hole diameter is rounded based off box length divided by 2. That is very descriptive to me. So even though I created that in my sketch by using hole diameter equals, and then I entered this value, this makes a whole lot of sense to me because I can tell exactly what it is and what I'm changing. So again, these are all things that we need to think about whenever we're creating these designs based on parameters or even just based on functions inside of your sketch dimensions. But there is one last thing that I want to cover, and that is limitations. So there are some limitations that we need to be aware of. And those limitations really are based on two things. One is going to be logic, and two is going to be driven dimensions. When I say logic, we do have things like seal, floor, and round that we can use to sort of trick the system, but we don't have logical operators like an if-then statement. An if-then statement can be extremely powerful, it just isn't in the user parameters yet. So you have to really think about things like rounding up or rounding down, using seal floor, using min-max, and then you can build your logic around those. Knowing the limitations at the start of your design can really help you figure out the best path forward. And the last option is, again, the limitations with driven dimensions. As you saw, that sketch still appears to be underdefined, even though it is actually fully defined. So that is one downside to using the driven dimension. The other downside is that I found that driven dimensions often don't work inside of these logical operators, these functions like round. So you have to think about that, and I would suggest avoiding using driven dimensions if possible, because this driven dimension is easily available here in our user parameter. It makes the most sense to simply type in box extrude inside of here. It's going to give you the same result, and I found that there's really been no issue or no problem just using user parameters instead of using things like driven dimensions. If you really don't have a parameter that's driving that value and you need it for something, then think about ways in which you can restructure your design to get it. Or you can use that driven dimension and hopefully it won't cause you any problems in your formulas. But if you do, if you run into a problem where it doesn't seem to work, then go back and see if you can reformulate a parameter to drive that value. So that's going to be it for my user parameter video. I know this is quite a long video, about 45 minutes, but I thought it was important that we at least put all of the different topics and aspects together in one video, and you can jump around to the different points where you see fit in your designs. If you have any questions, as always, you can leave them in the video, or you can send me an email, support@caducator.com. Thanks for watching, and we'll see you in the next one.